Hello and welcome to the fourth topic of quadratics, where we will be looking at quadratic graphs. So here we have to sketch the graph of the following function and we find the coordinates of its turning point. So sketching the graph requires us 5 things to know. So whether the graph is positive or negative, the roots of the graph, the y-intercept, the minimum maximum point, which is called the turning point, and the line of symmetry. So if we draw a sketch of a random graph, this could be here, like this, and here we have 5 things to know. So first of all, we need to know whether the graph is positive or negative. So here, if we look at the coefficient of x squared, so basically when it's negative, the graph looks like this. When it's positive, the graph looks like this. So here we have a positive graph where a is greater than 0. So here we can see that the graph is greater than 0 because a is the coefficient of 1. Therefore here we'll have our graph which is positive. So first of all, we know that the graph is positive and will be facing this direction here. Now the second thing that we need to know from the graph is the roots, and the roots are those here. So roots or solutions, whichever you want to call them, are those points where they touch the x-axis. Now there's something called the y-intercept, where the graph touches the y-axis, which is here. Also there is a turning point, which in this case is the minimum point of the graph, and it is located over here at the lowest point possible. Also you have a line of symmetry, and the line of symmetry is usually the x coordinate of the turning point, and it is halfway between the solutions. So they have an equal distance and the line of symmetry is on the turning point. So now knowing this information, we can sketch the graph of y equals x squared minus 5x plus 4. So first of all, we found out that the graph is positive. So that is the graph here, x, y, 0, where it's positive. But we can't draw it yet because we didn't find the roots, we didn't find the y-intercept and the turning point. So here, what we can do to find the minimum or maximum point, which is called the turning point, we can find that and find the roots using completing the square. So here we use, we're going to solve point 4 and 2 using completing the square. So here we have a list of things that we need. So we're gonna find roots and the minimum point of the graph, because if the graph is positive, then in here we see that there is a minimum point on the graph, and if it was a negative graph, then there would be a maximum point. But because we're dealing with positive graph, we're dealing with a turning point that is a minimum. So here is an equation for completing the square, and we're going to do it like so. So when we get to this point, when we complete the square, we can use the formula, which is minus a and b, where a is here and b is here. So if we invert the a, which is 5 over 2, and we keep the minus 9 over 4 in a coordinate to find out the turning point. And now what we have to do is we found our fourth step for the turning point, which is here. Now we have to find the roots. So this is still y equals to the following. When y equals 0, so that is when the line is touching the x-axis, we plus 1 on the other side, we square root both sides, and we add the 5/2 to both sides. Now the value of x is 5/2 plus 3/2, or x equals to 5/2 minus 3/2, and this will be x equals to 8 divided by 2, which is 4, and x equals to 2 divided by 2, which is 1. So x equals 1 and x equals 4 are the roots or solutions to the graph. Now we can draw our graph because we know all the things that we need to draw our graph. Apart from y-intercept, because I forgot about y-intercept. So the y-intercept is when x is equal to 0, so y is equal to 4. And we do that because this is 0, when plugged in the x equals 0, and this is also 0, so we're left with 4. Now we plot the things we found on the graph. So these are the 1, 2, 3, 4 for the y-intercept. This is the roots, which are 1 and 4. So 1 here, 4 here, now we need to put the turning point, so that is 2.5, which is here, and minus 2 and a quarter, which is around here. So this will be our minimum point. And we draw the graph touching all the points, which is like this. And that is the question done. But I want to explain the line of symmetry. So the line of symmetry here would be x equals 5/2, because it's the first coordinate of the minimum point, plus it is an equidistance from the roots, and that's why it is a line of symmetry. Now we have another question, where the question asks us to sketch the graph to find coordinates of turning point and write out the line of symmetry, the equation of line of symmetry. So in here we need to do 3 things to answer the question. And now the y equals minus 2x squared plus 4x minus 3 is our equation to be solved. We can see that a is equal to minus 2. The coefficient of x squared is minus 2. Therefore, we can note first thing that the graph is negative and it will face like this. Now we need to find fourth and second, and fourth and second being the roots and the turning point. So first we find the turning point, which is if we complete the square for this one by plugging in our formula of, by plugging this all in, we're gonna get minus 2x minus 1 squared minus 1. And by looking at this, we use the formula, which is minus a and b for the coordinates. So minus a will be here, this will be inverted to 1, and this would stay the same, which is minus 1. So turning point is 1 and minus 1. Now we find the solutions. So when y is equal to 0, and then 0, so we plus 1 on both sides and divide by minus 2 to get us minus a half. And here, if we square root both sides, we see that there's no solutions to this equation, because there's no way that we can do an expression like this because of negative square root. Now this means that there are no roots or solutions, meaning that the graph is not touching the x-axis. Now the third thing we have to do is y-intercept. So when x equals 0, y equals to -3. And I've done it so fast because if we make this a 0, this will be 0, this will be 0, and adding them all together will give us -3 for the y. So y equals to -3. So 0, -3, y-intercept. We got our turning points. We have information that there is no roots or solution, so the graph will not touch the x-axis, and we have the y-intercept. So here we have no solutions, but we got a turning point at 1 and -1. So 1, -1, that will be here, and we got the y-intercept, which is -3. So here, and the graph will look like this. So what we have missing is our answer for line of symmetry. Line of symmetry is where the turning point is. So the line of symmetry will be x equals to 1. So here we go, we got our 3 answers expected, we sketched the graph, we have found the turning point, and also we have found the line of symmetry. Now in this question, we have to find the value of ax squared plus bx plus c. So we are given the points on the graph, and we need to find what is the equation for the following quadratic equation. So first of all, we notice that we have been given roots, and we have been given the y-intercept. So basically, to get the roots, what we would have done is that we would use one of the methods to get to the answer of x equals, and now we have to go backwards, and the easiest way to go backwards is by going by factorization, because it puts it into nice brackets where you work backwards. So if x is equal to -1 and x equals to 4 are the roots of the graph, then you go backwards and you make x plus 1 equals 0 and x -4 equals 0. So that means our products are x plus 1 and x minus 4 equal to 0. Now if we expand that, it becomes x squared minus 3x minus 4. But here what happens is that this is not done yet, because we see that the y-intercept here is -1, and here our y-intercept is -4, because when we do x equals to 0, y equals to -4. But y equals to -1. So what we have to do is to divide by 4 the whole equation to give us a fourth of x squared minus 3/4 of x -1. And that is our answer. So hope that you can do now exercises 2f. Basically, a quick reminder is that the minimum point or turning point, depending on the graph, which way it's facing. So here, if the graph is like this, then we have the maximum point. If the graph is like this, we have the minimum point here. The y-intercept is over here. The roots are here. And remember to label your graph properly, where you have to put x and y and 0 at the origin. That is it. Good luck with exercise 2f.